Assalamu alaikum friends, in this video I will tell you how we configure the temperature module in TIA portal V16 and how we can use it in the program with the s7-1200 PLC. So we will start the new project, create new project, and here we can give the number TMP temperature control name. Any you can create the name in project and then goes to the view project, and here so go to the add a device, and which device you have you can choose it from your this family. This is the very big family from the Siemens, and this which model you have you can select it here. This model I have CPU 15C DC and that article number and version 4.4, and click it OK. And then your hardware is ready. And first of all, in this CPU, how much you can put a lot of extension boards you can install. Here 101, 102, 103, R2. It's very long. If you can scroll it here at 9 extension cards you can install, and also with at the CPU have a one area that's called DB, that you can choose it from here. Here are many type of CPUs inside the internal analog inputs and outputs and communication boards, signal boards, battery boards, DIA, DQ, a lot of. But which this area I have a one BD for this temperature. I will fix here. You can also fix it here. RS485 also, which is running in for Modbus communication. But I have one that temperature module. Yeah, that's one. That one 6ES. That's the article number. I have a one channel, one this module, and you can simply pick from here and drop it here to the PLC. And now here this module is installed in your rack with this PLC CPU S7-1200, and also it's now showing it in your PLC device overview. Which things are here connected or like to be installed, this will be showing it here. How much digital inputs, that's showing here digital outputs, and that for high speed counters and pulses, which interface is here available. And this is now selected our one CPU and one is our temperature module, and that's I will download to the PNC first, and later on we will configure first, and later on we will design the program how we can read the temperature from field in the software and apply it into the industrial. Then click it load, and now is compiling this your new module, and continue without sensitization and make it stop all first, and then click it load. Because of first program may be inside the PLC, that start modules, all that finished are okay. PLC 1, downloading to the device completed without error, and start modules after downloading to the device, and let's finish. Now your hardware is ready, one CPU and one is your extension module. It's ready in the ready for programming, and then you go to directly in menu B. And first of all, you have to choose here where you configure your temperature module. How you can find this one? You have to go in move operations. We will, because of when you read the temperature and have after you have to must be go in any data registers. Must be you choose one move command, and first it here you have to put one data register which is the specialized for that siemens. You can take it this up and you can go it here devices and networks. Maybe you go to the device configuration. Yeah, this here you can go, and also right click and you can go to the properties, and as per shown here general, and general is what thing we choose first here, AI1 RTD X1 one channel. Also he name showing here, name of the component you can change the name to the suit your requirements. You can change your name, but this is the original name. AI analog input 1 XRTD means one single channel is readable inside, and this is our module name. And analog inputs, when you go, this will be shows you to the details of this module. Yani what's the details? He says channel address where you can write this where you can read the temperatures, IWAT, and that measurement type he says thermal resistors for wires, and PT100 standard range, and temperature conflict he says PT 0. That's 00, that's one, and his temperature scaling is what type? That's the in Celsius he will read, yani, and smoothing week 4 cycles. And also you can enable broken wire diagnostics. If you enable this one, after this one be as a safety purpose, but no need to be this one. And that the channel 0, and he is also giving the here details, and IO address he is giving at this, it's starting from 80 and end address is 81, because of this is the only one channel, this IO module, and that's automatic update, and this up process image, and this is the details of this model. Let's go back to the menu B, and here we can define that which data register. He says IWAT. IWAT, where is our temperature shows any at the main point, and after any data registers we can choose for read data register. I take this address in MD25. Any data register you can choose, any MD20, MD25, MD30, MD40, but that data register must be important thing is this IWAT you have to choose for this dB for reading the temperature. That pinpoint is comes your temperature, and that download to the first way PLC, and then click load, and then make it simulation on. So now first of all I change the display in decimal. After you can see understand this area, this display also I will change in decimal. Sorry, this one here to click, and sorry, this tag automatic and go to the decimal, And now is what's showing. This 251 is temperature showing at my pinpoint, but I can show you in the camera. If I have one camera here, where is the camera? Yes, first of all I have to select my camera with the here we can see we can find the camera app. Not this one. Go to in camera. That USB 2.0 is shown. Device is ready. And that what I like to show you, because of this is my panel and this is my thermocouple. Internal also I will show you. This is my PLC. And this is my temperature module, temperature sensor. This is the sensor, yani. When I give him little temperature, yani for example, see it will be increased, yani temperature. As you giving little hot, your temperature will be increased, yani. And if you like to now it's showing 313, yani. More if you little giving temperature, it will be go up. See, when I sliding to giving with hot yani temperature, it will be increasing. And if you like to be make it down, you can put it this one in water and after your temperature will be goes back to the reduced after. See, it's now when cold I am giving in water, it's going back to the cool. $270, $269. Oh, it's not dip water in. When you put it in too much cold water, after go back to fastly, yani 260. Because of I don't have now right now have a ice or something. I give you the ice, it will be goes more down, yani. And if I little giving the hot, it will be see for 70, 75 and 93, 94. Also, yani giving hot, yani. So as per this one, as per shown, your temperature is when increasing, And also later on how we can apply this temperature and use in the programs. Use in the program. Simply stop the execution here, simulation, and here you can put one contact here m0.5 I will use for this one execution, and here you can use the comparator commands. Yani. For example, MD25 how to monitor and use inside the PLC programs that I will choose. And this I for example I put 370 for example. When temperature is equal, then 370, and also one more command I will take it here. If this temperature is MD25 is less than 350, no, not that same we use that same like any here this one row we can make, and here we can use in this comparator. This is the greater than command and this is the less than command. MD25 it's less than when 350, that must be giving the data which you want any in the int or any data when you like to use, you have to tell it here, define it here and make it here one coil Q0.1 and that here Q0.0 Q0.0 and that's download to the PLC and make it load. Anything you can operating for example in cooling towers or for temperature furnaces, anywhere you can use this one for fans, blowers, whatever. Yani, this data you can use decimal. This also put in format in decimal, and see now my M0.5 is not on. My temperature is now 255 at the pinpoint and my is here 255 and I make the set point 350. When temperature is reached at the 350 or less than 350, our Q0.1 will be on. And if our temperature is increased then 370, after our Q0.0 will be on. Now our temperature is 255. So we will first, this is not less than also 350. If it's less than 350, it will be energize this one Q01. For example, when we're using in this program, we will using in the water cooler or look like any big cooling tower, and we define the 350 degree. Our water when go down cool from the 350 degrees, after our fan needs to be on, and that Q0.1 is your fan, and maybe another Q0.0 is you can using for when our temperatures go more high, we can run another fan also. That seem like you can design the control. And see, we make that first this one on, modify this one, make it on 05 on. When execution make, when you not make this execution, it will be not energize the any relay. Now our temperature is down yani from 253, and we decided here when it's go from 350 is less than 350, this Q0.0 have to be go on. Less than, if this is high than 370, our Q0.0 have to be on. I will little increase the temperature and see after what's happening. That Q0.0 must be goes to on. 370, I think so. Very high we will put, but no problem, it can be reached, I think so. As we giving the temperature to the sensor, it will be continuously going up. See, when our temperature reaches at the set point of 370, our Q0.0 will be on, and as heats go down, our Q0.0 will be stopped, and when temperature goes from the 350 less or less than yani 350, our Q0.1 will be on. This will be a, maybe this is a fan, maybe this is a blower or whatever, this is a yani pump. You can yani when choose this one, when temperature goes at the more down, we like to be fill the cold water, and when your cold water is temperature goes high little, that command will be work, and that goes at the low temperature, after that will be work. This depend on your logic, yani how you make the logic in the program, you can use at this purpose. Yani when your temperature goes high, you can run that one coil Q0.0, and when your temperatures go more down, yani how much set point you can, and this set points you can take at the HMI, and you can set from the HMI temperature how much temperature you needs for high, how much temperatures you need for low. And inshallah will be next lectures, I will show you how to use this data at the HMI, and how we can set from HMI, and how we can increase and decrease the set points, and how we can read the temperature and our status of our inputs and outputs, we can monitor with the HMI. Inshallah will be next lectures, I will show you. I hope you understand about this lecture. If not understand anything, you can send me message in comment section or send me email. I will explain you and give you feedbacks as soon as possible. Thanks for watching. Allah Hafiz.